Solid geometry. Solid geometry is geometry of three-dimensional space, the kind of space we live in. It is called three-dimensional or 3D because there are three dimensions: width, depth, and the height. Solid sub-properties such as volume. Think of how much water it could hold, and surface area. Think of the area you would have to paint. There are two main types of solids, namely polyhedra and non-polyhedra. Polyhedra solid is a solid made of flat surface. Each surface is a polygon, like a platonic solid, prism, and pyramids. Non-polyhedra are solids with a curved surface or a mixed curved and flat surface such as spheres, cylinders, cones, and torus. Platonic solid. On the picture, there are 5 platonic solids or regular polyhedra. For each solid, there is a printable net. This net can be printed onto pieces of card. You can make your own platonic solid, cut them out, and tape the edges together. Prism. A prism is officially a polyhedron, which means all sides should be flat, no curved sides. So the cross section will be a polygon, a straight edge figure. For example, if the cross section was a circle, then it could be a cylinder, not a prism. All the previous examples are regular prism because the cross section is irregular. In the other words, it has a shape with an equal edges lengths. Here are examples of an irregular prism: irregular pentagon prism, cross sections. Platonic solid is a convex polyhedron whose faces are all congruent convex, regular polygons. None of these faces intersects except at their edges, and it has the same number of faces that meet each other of its vertices. There are 5 platonic solids. We have tetrahedron, octahedron, hexahedron, icosahedron, and dodecahedron. Euler's formula deals with the three-dimensional shapes called polyhedra. It states that f plus b minus e is equals to 2, where f is the number of faces, v is the number of vertices, and e is the number of edges. This formula works only on the solid that do not have any holes and do not intersect itself. It cannot also be made up of 2 pieces stuck together, such as 2 cubes stuck together by one vertex. The Euler's formula works on a platonic solid. Activity. Verify the Euler's formula for each of a regular polyhedron by supplying the necessary information in the table below. We have in the first column the names of the polyhedron, and for the second column the number of faces, and the third column the number of vertices or points, and the fourth column is the edges. On the fifth column we have the Euler's formula f plus b minus e equals 2. As shown in this table, we can fully verify that Euler's formula, which is adding the number of faces and vertices, then subtracting it by the number of edges, we have 2 as an answer for all types of polyhedron. I hope you learned something new. Thank you for watching.